This video is about the inverse of a matrix. We are going to talk about the concept, we are going to talk about an application which we are going to perform over there, and we are also going to talk about the properties of the inverse of a matrix. So hello everyone, this is Rahul. I'm a math faculty, and yes, if you are here for the first time, then
Hey students, subscribe the channel, hit the bell and get all the notifications at your fingertips.
So now let us watch and learn the inverse of a matrix. Alright, so in order to find the inverse of a matrix, let us first of all know about the concept of the inverse of a matrix. The first concept says that this is a formula of how we are representing the inverse of a matrix. The formula is given as adjoint of A divided by the determinant of A. Now regarding adjoint of A, determinant of A, I have already made videos on YouTube, so you can just go and watch it, how we are finding out the adjoint and determinant. And anyways, I will do it here in the question itself, so you'll be able to get the idea about how we are doing the adjoint and the determinant. Now the inverse of a matrix is a three-step process. The first step is to find out the determinant of the matrix A. Let us say any matrix A is given to you. So the determinant of a matrix A needs to be found out. This is the first one. The second one is you need to find out the adjoint of matrix A. And the third one is finally you need to find out the inverse using this formula. So once you have found out the determinant, once you have found out the adjoint, now you are going to do the adjoint of A divided by the determinant of A. So that is how you are going to find out the inverse of a matrix. Now let me give you an example and show you how we are doing the inverse of a matrix. Alright, so we have a question in front of us. We need to find out the A inverse of the matrix A, which is given as this one. So we are going to follow the three-step process that I have just told you. The first step is to find out the determinant of the matrix A. The second step is to find out the adjoint of the matrix A, and the third step is to finally find out the inverse of the matrix. So to find out the determinant of the matrix, we will just follow the steps that we need to do for the determinant. If you don't know what these steps are, I will just tell you first to watch the video on determinants that I have already given, and also follow here so that you can totally understand how we are doing the determinant. So first what we are going to do to find out the determinant of A, we first of all need to multiply. Let us take the first row into consideration. So it depends. Actually for determinant you can take any of the rows into consideration. You can take the first row or the second row or the third row. That totally depends on your choice. So I am taking the first row into consideration, and the elements we are going to multiply every element on the first row with the cofactor of that particular element and add up. That is the way in which we are finding the determinant. So we are starting with the first element, that is 1. And what will be the cofactor of 1? That will be minus 1 to the power of 1 plus 1. And the determinant of the minor, which is 6, 1, 0, 2. Now how we are doing the minors? We just need to eliminate the concerned row and the concerned column of the particular element that we are taking. Since 1 is on the first row and first column, so we are going to eliminate the first row and the first column, and whatever is left, that is the minor of the particular element. So in this way we are going to continue for the second one also. Now we are going to add, and we are going to again start with the second one, 2 multiplied by the cofactor of 2. The cofactor of 2 will be minus 1 to the power of 1 plus 2. Why 1 plus 2? Because 2 is on the first row, so 1, and the second column, so 2. 1 plus 2 into the minor of 2. What will be the minor of 2? You need to eliminate the first row and the second column because that is concerning 2. And whatever is left, that is minus 1, 1, 2, 2. The determinant of that will be the minor. Minus 1, 1, 2 and 2. The determinant of that will be the minor. And finally, we are going to add 0. Now, since we have a 0, so don't you think we don't need to multiply anything else with 0? Because we know that whenever we are multiplying something with 0, the end result is 0. So if you multiply the if you multiply the cofactor of 0 as the method of determinant tells you, it is fair enough. But I don't think it is necessary because you are only multiplying that number with 0. So whatever the result comes, if you multiply that with 0, it is of no use. So we are keeping 0 just like that. Now we are going to the next step. Now what we are doing? Now we will be breaking the things. So the first one is 1 multiplied by minus 1 to the power of 2, that is again 1, multiplied by the determinant of this particular thing. So that will be 6 into 2, 12, minus 0 into 1, that is 0. So 12 minus 0, that is 12. Plus, now again we are doing 2 into minus 1 to the power of 3, now that will be minus 1 into, now we are going to do the determinant of this one, so that will be minus 1 into 2, that is minus 2, minus 2 into 1, that is 2. So minus 2 minus 2, that is minus 4. Minus 2, this is minus 2, minus 2 into 1, again 2. So minus 2 minus 2, that is minus 4. And finally, we are adding 0. Okay, so one more step and we are getting our determinant. So 1 into 1 into 12, that is obviously 12. Plus, now here, minus 4 into minus 1, that is 4. And 4 into 2, that is 8. And finally 0. So the answer we are getting is 20. So the determinant of A is 20. So that is the end of the first step of the 3-step process. The next step will be to find out the adjoint of A. So alright, step number 2, we are going to find out the adjoint of A. Now to find out the adjoint of A, we need to follow the steps that are given to find out the adjoint of A. So already I have given another video on adjoint of a matrix where we have chosen this particular matrix only to find out the adjoint. So I will just tell you to watch that video also, and also to watch this video, so that you can get an overall idea and you can be absolutely perfect with the concept of the adjoint of the matrix. So now let us start with the adjoint of A. So the process is, to find out the adjoint of A, we need to choose every element and we need to find out the cofactors of every particular element that is present in the matrix. That means all the 9 elements, we need to find out the cofactors of all the 9 elements. And after that, we need to put those elements in a new matrix and then do the transpose of that particular matrix. Again, for transpose, you need to just visit that particular video of adjoint of a matrix and you will be able to know what exactly is transpose of a matrix. So, to find out the adjoint of a matrix, let us start. The first one is, we need to find out the cofactor of this one. So, first of all, cofactors are given as, now in order to address the cofactors, we use A, and in the subscript we are using the address of the particular element. So capital A 1 1 will be the cofactor of this one. Why? Because 1 stands for the first row and that 1 stands for the first column. So this is how we are finding out the cofactors. So A11 means cofactor of this one, this particular element. So in order to do that, the formula is minus 1 to the power of the sum of these two, that is 1 plus 1, and along with that the determinant of the minor of this element. So determinant of the minor of this element That means you have to cancel this one, you have to cancel this one, whatever is left, that is 6, 1, 0, 2. 6, 1, 0 and 2. So that is A11. So let us proceed with the answer. So the answer will be minus 1 to the power of 2, that is simply 1, and 6, 2, 0, 1. The determinant of that will be 6 into 12 minus 0, that is simply 12. So 12 into 1 will give you 12. Okay. Then A12. So A12 will be minus 1 to the power of 3, and the minor will be this one and this one will get cancelled. So minus 1, 1, 2, 2. Minus 1, 1, 2, 2. So that will be minus 1 into 2, that is minus 2. Minus 2 into 1, that is 2. So minus 4 in total into minus 1, that is simply 4. Okay. So I will tell you once again that whatever I have done, I have already jotted down this 1 plus 2 directly. So I am not doing this again and again. So I have just shown you the first one, and I will be continuing with the same logic. Okay, I will be explaining how I am getting. Okay, with the same logic I will be continuing. So A12 is 4. The next one, A13. So A13 will be minus 1 to the power of 4, and the minor of this one. So minor of this one will be minus 1, 6, 2, 0. So minus 1 to the power of 4, that is simply 1, and this will be minus 1 into 0, that is 0, minus 2 into 6, that is 12. So minus 12 into 1, that is minus 12. Okay. Okay, one more thing, side by side, I am also writing the newly formed matrix so that I don't have to write it again and again. So once I found out a particular number, I am going to write it on the matrix over there. So 12 I had found out for the first element, so here I will write 12. 4 I found out for the second element in the first row, so I will write 4 here. And minus 12 I found out for the third element in the first row, so I will write minus 12. Okay, let us go with the next 3. So the next 3 will be, we will start off with this one. So the address of this will be, so this is on the second row, so 2, and on the first column, so 1. So the formula will be minus 1 to the power of 2 plus 1, and the minor of this one. So minor of this one will be, you need to cancel this one and this one. So 2002. 2002. Okay. So the result will be minus 1 to the power of 3, that is minus 1, and here it is 2 into 2, 4 minus 0. So it is 4 into minus 1, which is minus 4. So we are writing minus 4 here. Next, A22, second row, second column. So it will be minus 1 to the power of 2 plus 2 and modulus, or the determinant of the minor. So second row, second column. So this one. So if you cut the concerned row and column, what is left? 1, 0, 2, 2. So it will be 1, 0, 2, 2. So what we are getting? 1 into 2, that is 2, minus 2 into 0, that is 0. So 2. And here also there is minus 1 to the power 4, that is simply 1. So here 2 minus 0, that is simply 2. So answer will be 2. Next, A23. So it will be minus 1 to the power of 2 plus 3 and we are going to write the minor. So minor of this one, second row, third column, second row, third column. Minor of this one will be 1, 2, 2, 0. We need to cut this one and this one. So 1, 2, 2, 0. So the answer to this one will be, so this will be minus 1 to the power 5, which is minus 1. And this will be 1 into 0, that is 0, minus 4. So it will be minus 4 and multiplied with minus 1 will give me 4. Okay. The last three. So finally this one is third row, first column. So it will be 3, 1. So this will be, if you talk about the minor, so this is third row, first column. So we need to eliminate this one and this one. So it will be 2, 0, 6, 1. 2, 0, 6, 1. The answer to this one will be, now see, 3 plus 1 is 4, so minus 1 will be plus 1. And here 2 into 1, that is 2 minus 0. So simply 2. A, 3, 2. So minus 1 to the power 3 plus 2 and the minor. So 3, 2. This is third row, second column. So this one. And minor of this one will be, so you need to eliminate this. And what is left? 1, 0, minus 1, 1. Eliminate this one and this one. Yes. 1, 0, minus 1, 1. So the answer will be, so this one is 3 plus 2, that is 5. So minus 1 will be there. And this is 1 minus 0. So 1 into minus 1. The answer will be minus 1. Okay. And finally A, 3, 3. So A, 3, 3 will be minus 1, 3 plus 3 and the minor. The minor will be, so 3, 3, third row, third column. So we need to eliminate that. The minor will be 1, 2, minus 1, 6. 1, 2, minus 1, 6. So that will be, so minus 1 to the power of 6 will be 1. And here it will be 6 into 1, that is 6, minus 1 into 2, that is minus 2. So 6 minus minus 2. Let me write it again. So it will be 1 to the power of 6, that is simply 1, no need to write that. So this one will be 6 minus minus 2. 6 minus for the determinant and minus 2 for this particular product. So it will be 8 in total. So this is not actually adjoint of A, to be honest. There is one more step that is remaining. For adjoint of A, we need to do the transpose. So we have found out the cofactors for the adjoint of A. Now we are going to do the transpose of this particular newly formed matrix to finally get the adjoint of A. So after transposing, now what is transpose? So transpose means, as you can see here, the first row is 12, 4 minus 12, second row is minus 4, 2, 4, third row is 2 minus 1, 8. Now if you interchange the first row as the first column, let's say the first row here is 12, 4 minus 12. So instead of being the first row, that now becomes the first column. So it will be 12, 4 minus 12. The second row becomes the second column. Minus 4, 2, 4. That was the second row. Now it becomes the second column. So minus 4, 2, 4. And the third row becomes the third column. Third row is 2 minus 1, 8. Now it becomes the third column. So 2 minus 1, 8. So this is known as transpose of the matrix. So this matrix has been transposed. Transpose comes from the word position, transposition, transfer of position. That means we are transferring the position from row to column. That is the transpose. And that is the final result for the adjoint of A. Final result for the adjoint of A. Now finally, the last step, that is, we have now found out the determinant, we have found out the adjoint. Now we are going to simply divide the adjoint with that of the determinant, and that will give us the final value. So finally we are into step 3, the last step to find out the inverse of matrix A. So in the first step we had found out the determinant, the second step we have found out the adjoint, and now we are going to use the formula to find out the inverse. So A inverse will be the adjoint divided by the determinant. So the adjoint will be this one. So it is 12, 4, minus 12, minus 4, 2, 4, 2, minus 1, 8. So this is the determinant, this is the adjoint of A, and the determinant is 20. The determinant is 20. We can keep it like that, or we can take 2 common out of here. Okay, so like this also we can simplify the thing also. Okay, that is totally depending on the question that is given to you or the options if necessary. So we can keep it like this only. So that is more than enough to find out the adjoint. That is more than enough to get the answer of the inverse, not adjoint, sorry, inverse. So I hope you have understand the entire process, how we have found out the inverse of the particular matrix. So finally we have come to the last part of this particular video, that is the properties of inverse of any particular matrix. So these are the few properties that you need to remember while you are applying for inverse of any particular matrix. So the first one is A dot A inverse, that will be equals to A inverse dot A, that will be equals to I. So anything can come first, the matrix can come first followed by its inverse, or the inverse can come first followed by the matrix. The product of both will give you I. I stands for the identity matrix, that means the identity matrix of that particular order in which the matrix is. Then A dot B whole inverse will be B inverse dot A inverse. A dot B dot C whole inverse will be C inverse dot B inverse dot A inverse. These rules are just as usual, you need to just follow these particular rules while you are going for inverse of any particular square matrix. And finally, for non-singular matrix. So what is non-singular matrix? Whenever the determinant comes as a non-zero value. When the determinant is 0, that matrix is known as a singular matrix, and if the determinant is non-zero, that matrix will be a non-singular matrix. Now if it is so, then the transpose of A and the inverse of that will be equals to the inverse of A and the transpose of that. So it is just, you can reverse the particular thing, you can just interchange the particular powers here. The second one is A to the power theta. Theta stands for the transposed conjugate. Whenever A is a complex matrix, theta is the transposed conjugate of that particular value, and that to the power of -1. And similarly, you can put -1 and theta, you can interchange the places. So that is all about the properties of inverse. And with this, we are ending up today's video. I hope it was helpful for you, and from now on our videos will be exactly like that. We are going to execute the different problems so that you can get a better idea about the concept. So we will see again on the next video. Bye bye.